Happy.
Alright, so what I would like to demonstrate today is diagnosing a lamp matrix issue with a Williams System 11 pinball machine using a lamp matrix test board. First, what you need is a lamp matrix test board and some other good tools to have to diagnose these issues is a logic probe, a multimeter, and an instruction manual that has the schematics for the lamp matrix. For my demonstration, I'll be using a 1986 Williams high-speed pinball, which is a System 11. I have placed the pinball machine in a test mode for the lamps, where all lamps pulsate. And the way you do this is when you turn on the machine, you press down on that center red button and turn it on, and you're able to navigate to the all lamps test to be able to pulsate all of the lamps within the matrix. What I've already done is I've connected the lamp matrix test board to sockets 1J6 and 1J7. These are the rows and columns for the board, and the way you can check this is if you go to the high-speed manual, there's a lamp matrix table, and within the lamp matrix table it shows the connectors. You can see the column is 1J7 and the row is 1J6. With the test board, you can see with this machine that row 1 is having an issue. It's not being illuminated. And this corresponds to the row column, which is the 1J6 pin number 1 that is causing an issue on this machine, where the entire row is out. With the test board connected to the MPU of the System 11 board, you can isolate the problem as being at the board level. Since you're connected to the 1J6 and 1J7 with the test board, you're not connected to the playfield. And so this means that the problem is not at the playfield level, it's at the board level. What we've determined is row 1 in the lamp matrix is not working properly, and so we go to our manual and we go to the schematic, and for the Williams high speed it is page number 50, looks like 52, and so we have the corresponding 1J6 pin 1, and what we want to do to diagnose the problem, since we know it's at the board level from the lamp matrix test board, is trace back from LJ16 or LJ61 through all these components and determine which component is failing. The first step that I want to take to diagnose the problem is to connect my logic probe And to do that, I need to connect it to a 5-volt power source. And on the System 11 board, this is the location. And there's also a ground. And I like this location because it's clearly marked for the 5-volt and the ground. And that's where I connect it. Now there is another location which is on the power supply, which is considered TP1, which is 5-volt, but it's not as clearly marked. And then you need to find a ground, which could be anywhere on the back box, to connect your black wire to. But I prefer this location on the System 11 board. So what we want to do is start at the end of the circuit, like our schematic shows, where we have our pin 1J6-1. And what I do is I find another circuit which is very similar to the one that has a problem, which is the next one over, which is 1J6-2. So we have 1J6-1 that has the problem, 1J6-2, which is functioning correctly. And so we can start with pin 1 with our logic probe and see how it reacts, and compare it to pin 2 and see how it reacts. And then you go down the circuit and you follow the schematic. So the schematic says that Q80 is the next component in the circuit. For the next one that is functioning correctly, it's Q81, so we can compare the two. So the next component is a transistor, which is a TIP 122, which are these right here. And this is the one that's giving us an issue, and this is the one that is functioning correctly. So we can compare the results between the two, and I can connect to what I call the third leg, or the third pin. And on the one that's functioning correctly, you can see the alternating tone and the low that's alternating. On the one that's not functioning correctly, it is just solid. There is no pulse. If you use your multimeter and you find out that the TIP 122 is not the problem, you move down the line. So the next component that you can check is the S1, or compare it to the S2. And if you use your logic probe, you can compare and see if they act the same. And you can see S2 pulsates, but S1 is solid on this leg. So if you find that S1 is fine in this case, and it matches S2, you can move down the line and down the circuit, and you can follow your schematic. So for this circuit, the next component is D4, and you can see these diodes and resistors, and they're in a row here, and they match between the two circuits. And you can compare the two because you know that the lamp matrix test is running and it's pulsating and flashing. So if we look at R1, for the circuit that's bad, it's solid. For D4, it's solid. And for D5, it's solid. But let's compare it to the next circuit. And it's pulsating. And the next one, it's pulsating. And the next diode, it's pulsating. Or no, that one is solid. So the center one is pulsating, the top resistor is pulsating, but compare that to the bad circuit, you can see that resistor 111 is solid and diode 4 is solid, which does not match the other circuit. So we know there's a problem still in this area. So on this issue, we keep moving down the line. If you look at the schematic, we next review U55. And U55 is right here. And U55 is a 7406N integrated circuit. And so what I've done is I've printed out the pinouts for this circuit. And it is right here. And this one is upside down, so I flip it over. And according to the schematic, which is right here, that this circuit that we're having a problem with is connected to pin 13 and 12. On the integrated circuit for 7406, the bad circuit uses pins 13 and 12, but the one that we're comparing it to uses 11 and 10. So we can compare the two with our logic probe, and this is how it looks. And this is U55, and pin 13 on the bad circuit, we can connect to it, and there is nothing, it's dead. This should match pin 11 on the good circuit, and pin 11 you can see is pulsating, but 13, which is here, is not creating any activity on our logic probe. Next, we keep moving down the line of the circuit, and if you look at the schematic, U55 is what we just looked at, pins 13 and 12, really 13. And the next connectivity is to this chip here, which is U54. It's a PIA. And if you look at the schematic, you'll see that it's very hard to read, but it says PA0, and the good one is PA1. And if you look at the chip here and the schematic, hopefully you can see it, and look at PA0, it is right here, really hard to see, but it is on pin 2. And the good circuit that we're comparing it to, which is PA1, is on pin 3. And this is where you look. So we want to use our logic probe and look at PIA, the PIA chip on U54. So we know the good circuit on pin 3 is right here, and it's pulsating. We know the bad circuit, which is on pin 2, it's pulsating too. But we have found that between the connectivity of U54 pin 2 and U55 pin 13, that it is not responding whatsoever we'll look at that again. So 13 should connect to pin 2 on U54 or U55. So this is pin 2. And it is pulsating like it should. And then we go to pin 13, which is a 7406 integrated circuit, which is right here. It is not doing anything. So there is a problem between these two chips. There's no connectivity on this pin. So I'll show you here in a minute that if we have a jumper and we jump these two, then the lamp matrix test board will show that that row is functioning like it should. So what I've done to just prove that that trace is bad and that we've traced it all the way back through the schematic from that pin on 1J61 all the way to the chip on U54, the PIA, and that's where the problem is between U54 and U55, is what I can do is I can jump it with a wire, and on pin 2 on the U54 and pin 13 on U55 I can connect the two, and I'll show you once I do that how on the test matrix lamp board that one row that's out will start pulsating like it should. So here I go, connecting the two. And you'll see, it's hard to do, but you'll see that it's pulsating. That one row is pulsating like it should. And so what we've done is we've traced it all the way back to the PIA, and there's a bad connection between the two chips. And what we need to do is take that board out and figure out why there is a bad connection. But when you're troubleshooting these lamp matrix issues, the lamp matrix board helps a lot because it tells you that the problem is with the board and not underneath the playfield. And then you start with the schematic and you trace your steps back as far as you can, especially before you start replacing components, because you want to make sure you don't replace something that you don't have to. And a real common failure is that TIP 122. And the next thing that I wanted to replace before I figured out the issue was that 7406 integrated circuit. But come to find out, it's the trace between the PIA in slot U54 and the integrated circuit in U55. So I don't have to replace any chips, I just need to fix that trace. So I hope that helps somebody when it comes to tracing these issues and figuring out these issues, that first you need to isolate the problem to the board and make sure it's not under the playfield. And this lamp matrix test board helps with that because we're not connected to the playfield. And then you trace back using the schematic from the row or the column that's giving you the issue, and you trace back through those components as far as you can until you find the problem. So I hope that helps you out. Another thing I wanted to show you is that in this case there was a board issue, but there's also a playfield issue. Previous owner, I think to accommodate the problem with the board, they connected the lamp matrix to another row so that the lights would illuminate, although they were illuminating in the incorrect order. So what I discovered using my multimeter is that there was a short in the playfield between 1J61 and 1J63, and that allowed the lights to illuminate for the dead row, but they were illuminating in the wrong order. And so not only was there a board issue, but there was a short in the playfield. And so I tracked that down, and as you can see, row 1 is a red-brown wire and row 3 is a red-orange wire. And what I found, and I marked it, is that a previous owner took this gray wire here, and it's hard to see, but it's connected to the red-brown wire, and then it's also connected to the red-orange wire, which is causing the short in the playfield. So what I did to fix that is I disconnected this cable here, this wire, and removed the short. And so when I replace or I fix the bad trace on the board, that it will function correctly. So make sure that not only your board is fixed, but make sure the playfield is also functioning correctly and that there's not any shorts, because that would cause a problem. Once I fix the board, that would continue to cause a problem. So thank you for watching. I hope that helps you diagnose some of the lamp matrix issues that you may have with the Williams System 11 pinball. The lamp matrix test board really helps out a lot, and one of the other tools that you want to have is that logic probe, and it really helps diagnose these types of problems. So I hope it helps, and thank you for watching.